Okay, so let's take a look at a circuit that looks something like this. I will have I have that. Okay, all right, so let's say that I have this circuit. So I've got a current source, and I'm saying it's 2 milliamps. And I've got some resistors in here of various values. I can make them, let's see, and then I'm calling this VL over here. This is to make it look like similar to this one. These are in kilo ohms, and that's our unknown. All right, so 2 kilo ohms, 1 kilo ohm, 5 kilo ohms, and R, and we want V, it doesn't matter, I'll make that plus, that minus, and I want to choose R so that VL is 3 volts. Chances are, since I just made this up, I did something that's impossible, but let's try it and see. Okay, so I am first going to do a source transformation on this current source and resistor, because I like to do, I don't like current sources, I prefer to have voltages. Now I want to be really careful with R here that I don't, and with VL, I don't want to, if possible, I don't want to mess with those, because source transformations can really change the properties of the things that you're transforming. What it doesn't change is the rest of the circuit. So when you do a source transformation, you are transforming those things, you are changing them. It doesn't change everything else. Okay, so when I change this to a voltage source, this is a good problem because it illustrates several things. And so this stays 5 kilo ohms. The voltage, V equals IR, that will be 2 milliamps times the resistance, 5 kilo ohms. And a milli and a kilo cancel each other out, so that would be 10 volts. So I have 10 volts right there. And now I want the voltage across right here to be 3 volts. So I can see that the voltage from here to here, I can see, you may not, because it's maybe the first time you've seen this, that this voltage is equivalent to the voltage across the 1 kilo ohm resistor. So if this is VL, this is also VL. Let's say I make this ground. And the reason why is, even though there is this 2 kilo ohm resistor right here, it's not doing anything because it's an open circuit. And so, so this voltage right there is in parallel to this. So if I can get the voltage across the 1 kilo ohm resistor, then I will have the same as the voltage across these two terminals right here. So have y'all done voltage division? Okay, so voltage division is very useful, and I think it is mentioned in the book, but you just might not have done it in class, so I think it's useful to talk about it because you will be using it in other classes. So I'm going to talk about how voltage division works. So let's say I have, so this is just kind of an aside, I have, well, I have 2 resistors in series, and I know that I'm just going to say, well, I'll call this voltage VA, and I'll call this voltage VB. And this resistance I'll call R1, and this resistance I'll call R2. So they're in series, so the rest of the circuit is going off and doing something else. They're in series, and so that means they have the same current going through them, but they have different voltages across them. So if I want to figure out the voltage across R1, now keep in mind what I'm finding is not an absolute voltage relative to ground. I'm finding the difference across R1 from one side to the other. So the voltage across R1 is going to be, I take the total, I'll just call that plus and that minus. I take my total voltage, which is VB minus VA, times, and then it would be R1 over R1 plus R2. And that would get me what the voltage drop was across R1. So as an example of this, let's say I had lovely resistors.
What's the R1 divided by R1 plus R2 from again? And what formula?
This is voltage division. So I think I might be introducing it to you. I believe it's mentioned in chapter 2 in the book.
I wasn't there for a lot of the lessons, so I'm kind of hazy on what that is.
Okay, well, I'm explaining it right now. I'm giving you an example that'll show you what I mean by it. Okay, so this is going to be an example with real numbers that'll show you what this actual means. So let's say I have a 12 volt voltage source, and this is a 2 ohm resistor, and this is an 8 ohm resistor. And my problem that I'm being asked to find is what is, let's say it's labeled like this, what is VA, where VA is the voltage across the 2 ohm resistor. There's a lot of ways to do it. So the simplest, instinct way to do it is to say, well, I know that in my entire circuit, V equals IR. My voltage across both resistors is 12. I don't know my current. My total resistance, since these are in series, is 10 ohms. And so I is 12 over 10 amps. So now, if I want to get the voltage across the 2 ohm resistor, so across the 2 ohm resistor, I can say that is also V equals IR, but I'm just looking at a different voltage. I'm looking just at this resistance, and so it's the V that I'm solving for. It's going to be 12 over 10, because that's our current. Everything is in series, so the current has to be the same everywhere. So the current times the resistance, which would be 24 over 10, or 2.4 volts.
That's the voltage loss between 2 points.
Right. And then we know if it's 2.4 there, then across the 8 ohm resistor would have to be 9.6 volts. And that's KVL going all the way around the loop, because we have to get all the way around. But what we do a lot of times, and so this is, a lot of things that you do in electrical engineering is, okay, well, right, but we kind of have a quick and easy way to get it as well. And this is voltage division. So voltage division tells me that if I know the total voltage across both of them, which is 12, then the voltage across the 2 ohm has to be my total voltage, 12, times the resistor that I'm looking at over the sum of the 2 resistors. That's 12 times 2 over 10, which is 2.4 ohms. Now, you might have noticed, well, that's exactly the same calculation we ended up doing over here. And that's because it is. This is just kind of a shortcut for getting there. Okay, so that's voltage division. So when I'm looking at this circuit right here, the one in my problem, and I want to get the voltage across this. The first thing I think is, voltage division, because what I have is just a simple series circuit. I happen to have this other 2 kilo ohm resistor over there, but it's not doing anything. So all I have are resistors in series, and the top branch there, that's equivalent to a resistor. So if this is 1 kilo ohm, this is equivalent to 5 kilo ohms plus R. Now, I said you want to be careful when you transform things, and I want to make sure that what I just did is not going to change my problem, and it doesn't, because everything is in series, and treating these two as one resistor, equivalent resistor, is not going to affect the voltage across the 1 kilo ohm resistor, so that hasn't changed anything. So now my problem said I wanted VL, so that's going to be right here. I wanted VL to be 3 volts. So VL is the voltage across that 1 kilo ohm resistor. Using voltage division, the voltage across the 1 kilo ohm resistor is going to be the voltage across both resistors, which has to be 10, times 1 kilo ohm over the sum of both resistors, so 5 kilo ohms plus R plus 1 kilo ohm. So that is what I'm looking for. And then in this particular problem, we said we wanted the voltage to be 3 volts. So I'll put 3 in there. It says 3 equals 10 times. Now if I just say R is in kilo ohms, I can cancel out the kilo ohms from everything. 1 over 6 plus R. Or multiply both sides by 6 plus R and divide both sides by 3. 6 plus... Please tell me I'm ending up with a negative resistance. Okay, I told you this would happen, that I'd make up a problem I'll end up with, and I couldn't even think of what the ridiculous thing is. A negative resistance is ridiculous. So you can't have a negative resistance. But that's what I've got. 10 over 3 minus 6. So R equals, it's something not possible. But that's because I made up this problem. Right. So the reason that's not possible is because no matter what, the resistance on this side, on the 5 kilo ohms plus R, this resistance is going to be bigger than the 1 kilo ohm. So it has to have a higher voltage drop than the 1 kilo ohm. The bigger the resistance, the more the voltage drop will be. And so the voltage drop on this side has to be bigger than the voltage drop on this side. I only have 10 volts to work with. And so, no, that should be okay. 3. Did I do something wrong? Let's see. Now that should be possible. So what did I do wrong? 1. No, it's not possible. It's not possible because, okay, so if these things were equal, so if I had exactly the same up here as down here, so if this was 5 and this was 5 and I had 10 volts to go across them, I would have a drop of 5 volts here and a drop of 5 volts here. So, to get 3 volts here, I would need to have less resistance on this side than I've got. It wouldn't, this resistance is too small to get 3 volts. That's why it's ending up that R would have to be negative. But the whole process works fine. So did y'all have any questions on that? Did that make sense? Okay, did you have another question you wanted to ask related to this problem, like maybe another way to work it?
No. Honestly, I just need help on like almost all of them.
On almost all the homework. Well, why don't I just keep looking at it and coming up with new stuff? So let me stop